Hi, this is Sudeep, and I welcome you back to this wonderful journey of learning structure analysis with StatPro. In the last couple of sessions, we had taken up two statically determinate structural problems and we had solved for the reactions of those structures using the equations of equilibrium. In this session, the idea is to continue the discussion on equations of equilibrium by revisiting the same two problems and see if we can reuse the equations of equilibrium in an alternative way and if the usage or the alternative usage that we will show would be valid. But before we do that, please to take a moment to hit the subscribe button and join us in this wonderful journey of learning structure analysis with StatPro. But before we go forward, please make sure that you have seen the last couple of sessions where we have solved the two problems that we have mentioned. And even before that, you would need to look at the session that we did at the beginning of this particular series where we had discussed about the equations of equilibrium. Now, in order to access that session, you can click on the link that is appearing on the screen right now to visit that particular session. Now, you may remember that this was the first structural analysis problem we had solved the reactions for using the equations of equilibrium. Now, let us try and solve the same problem in a different way. We already have the solutions indicated in this particular figure, and we had seen that if we take the summation of all the forces along the x direction as 0, we will get the reaction R1H as 36 kips. Is the same as before. But instead of having or considering the moment at node number 1, what we have now done is we have considered a node number A where at the position where the 60 kips load has been applied, and we are trying to take the moment about that particular point. Now, you have seen that we have resolved the inclined 60 kips load into its vertical and horizontal components. Now, what will happen if we take the moments of the applied forces and the reactions about point number A? Now, you have to understand that at this point, we have already used the equation sigma fx is equal to 0, and we have already solved for R1H. So we already have the solution of R1H as 36 kips. Now, but we are yet to solve for R1V and R2V. Now, this 56 kips and 52 kips shown here comes from the solution that we had done in the earlier session. Now, what will happen if we take the moments of the applied and the reactive forces about the point number A? So we'll see that the R1V reaction would create a clockwise moment, and as you know that we are considering the moment about the z-axis, so the anti-clockwise moment would be positive here. If you are not sure of what I'm telling about, you can revisit the earlier sessions where I have discussed this. Now, since we are considering the anticlockwise moment and as positive, we now have R1V, which would create a clockwise moment about node number or point number A. And what would be that moment? The distance of that reaction R1V is 6 feet, and thus the moment would be minus R1V into 6, because minus, why it is minus or a negative sign? Because it creates a clockwise moment from the assumed direction of R1V. Of course, we will find out that the in later that the assumed direction is correct. Okay, and then next thing that we have is the applied vertical load of 48 kips, which is situated at a distance of 6 feet from point number A. That too would create a clockwise moment of magnitude 48 into 6, and since it's a clockwise moment, it would be preceded by a negative sign. The applied load of 60 kips won't create any moment because it's acting right through point number A. And the horizontal loads, both R1H and the load of 36 kips, are passing through point number A, so that won't create any moments either. So the only other force that is left is the reaction R2V. Now this R2V would create an anticlockwise moment about point A, and it is situated at a distance of 12 feet. So we'll have a positive R2V multiplied by 12, and if we set them equal to 0, we find that we derive an equation which has two unknowns. Now, let us think about the other equation of equilibrium, which is summation of the forces in the y direction is 0, or sigma Fy equal to 0. And in that case, our assumed direction of R1V and R2V are along the positive direction of the global y-axis, and thus R1V and R2V would be positive, and then the applied load of the applied vertical loads would be minus 60 kips, minus because it's acting opposite to the global y-axis, or the positive direction of the global y-axis, and minus 48 kips for the same reason. And if we go on, we will see that we have derived another equation which again has the same unknowns as the first equation. So we have actually derived two equations, equation 1 and equation 2 with the two unknowns R2V and R1V. Now if we solve these simultaneous equations, we will solve for both R2V and R1V. But we can see that this creates a bit of inconvenience if you compare that with the solutions that we had done in the previous session, where we had got we have used sigma fx equal to 0. Now it is the same thing that we have used here as well, but in this case what we had done, or in the earlier case, in the earlier session, what we had done is we had taken the moment about point 1, which had made the R1V term to disappear, because R1V, which was the unknown, which was one of the unknowns, was passing directly through point number 1. So that won't create any moment. So we had only one unknown in that equation, and thus we had solved directly for the R2V, right? And then we had substituted the value of R2V in sigma Fy equal to 0, and we had directly solved for R1V. The point I'm trying to make here is that you can take the moment about any point in the plane. That is perfectly fine, but that might create inconveniences. So you have to apply some ingenuity in solving these problems, which, what I mean to say is that you have to be clever enough to select the moment equation at specific points which would give you an advantage in solving the reactions of the structure. Now let us revisit the same structure analysis problem that we had solved and we had been talking of. And now what we intend to do is to solve again for the reactions of this particular structure, but this time using alternative equations of equilibrium. Of course, we will apply ingenuity to solve this problem so that we do not run into inconvenience while solving this. So what we will now do is indicate those equations of equilibrium that we will use to solve the problem. But before doing that, let me also tell you that I have already written down the solution of the reactions in this particular figure. Now this solutions comes from our early solution of the problem that we have just also discussed. And now what we will do is we will try and compare the results that we will obtain from this new set of equations of equilibrium with the results that we have already obtained. Now, let us first consider this particular equation, sigma fx equal to 0. Now, imagine that you do not know about the reactions or the value of the reactions of the structure. So what we will do, we will assume the unknown reactions, the R1H, which would be the horizontal reaction at H, R1V, which would be the vertical reaction at V, and R2V, which would be the vertical reaction at node 2 in their positive directions. Now, why there are two reactions at node number 1 and why there is only one reaction at node number 2? This is because node number 1 had a pin support and node number 2 had a roller support. Now, okay, now what we'll do is if we solve this summation of fx equal to 0, now since we are assuming R1H along the positive direction, so we'll have a positive value of R1H, and then we have one applied load which is acting in the negative direction, which is the load of the horizontal load of 36 kips, and it's acting along the negative direction of the global x-axis. So we have R1H minus 36, and we put that as 0, and we solve R1H as 36 kips. Okay, now that is what we had already got in our earlier solution. Now what we do next is we now solve for the condition that the moments of the applied and the reactive loads about point number 1 about z-axis is 0. So what we'll now have, so we can see that the moments due to R1V, R1H and the applied load of 36 kips need not be considered because they would act through node number 1, and thus there would be no lever arm, and thus they cannot create any moment. So what are the loads that would create the moment? Well, the first load would be R2V, and it would create an anti-clockwise moment. Now since R2V is at a distance of 18 feet, so we have a positive R2V multiplied by 18 feet as the moment. And then we have the 60 kips load, which would create a clockwise moment about node number 1. It is situated at a distance of 6 feet. So the moment would be 60 into 6 feet. It would be preceded by a negative sign since it creates a clockwise moment. Same for 48 kips, which is located at a distance of 12 feet from node number 1. Now, all of this are equated to 0, and we can solve directly for R2V, and the value comes out as 52 kips, and we get the exact same value that we had obtained earlier. Now, instead of using sigma Fy equal to 0, let us try and use sigma mz2 is equal to 0. Now, if we take the moments about point number 2 as 0, so what are the forces that we are ruling out? We are ruling out that the load of R1H, the reaction of R1H, the reaction of R2V, and the applied load of minus 36 kips. So what we first have is R1V, which would create a clockwise moment about node number 2. So minus R1V multiplied by 18 minus because it creates a clockwise moment. And then we have the 60 kip load, which creates an anti-clockwise moment about node number 2. Now since 60 kips is situated at a distance of 12 feet from node number 2, the moment would be positive 60 multiplied by 12. And finally we have the load of 48 kips, which is located at a distance of 6 feet from node number 2, and it will create an anti-clockwise moment. So we have plus 48 multiplied by 6, and we can sum that to 0, and we will solve R1V as 56 kips, as we have got in the earlier solution as well. Now I have a question for you. Do you think that using these alternative equations is correct. Yes, it does give us the same results that we had obtained from the earlier solution, but is using these equations sigma fx equal to 0, sigma mz we have used two times, once about node number 1 and once about node number 2. Now, do you think using of these equations are correct to solve for this reaction? If not, what is wrong? I would like to see your comments in the comment section below. And based on whoever comments on this particular problem, I will do a live session very soon and I will invite all of those who have commented on this particular problem. I will give the answer to the question that I have posed in the next session, and I will also explain the reasons thereof, which would be very interesting to know. I hope you have enjoyed the session. If you have, please do hit the like button and do join us in the session next week. Till then, bye bye.